In this video, we're going to talk about properties of vector addition and scalar multiplication in the plane. Recall that a vector has two defining characteristics: direction and magnitude. And also recall that the geometric representation of a vector in the xy plane is represented as a directed line segment whose initial point is at the origin and whose terminal point is represented by some coordinate pair. As we discuss the properties, we're going to let u, v, and w represent vectors in the plane. We'll let the letters c and d represent scalars. The first property we'll talk about is closure under addition. So property 1, vectors in the plane are closed under addition. This means that if u is a vector and v is a vector, both in the plane, then u plus v is also a vector in the plane. The second property we'll look at is the commutative property of addition. That is, vector sum u plus v is equal to vector sum v plus u. For property 3, the associative property of addition holds with vectors in the plane. Property 4, the additive identity property, says that vector u plus 0 equals vector u. The additive inverse property tells us that vector u plus the negative of vector u is equal to 0. Property 6 tells us that vectors in the plane are closed under scalar multiplication. Similarly, for property 8, if we have the vector sum c plus d, the sum of two scalars c plus d, and multiply them by vector u, that is equivalent to saying c times u plus d times u. The ninth property deals with the associative property of multiplication. The 10th property for vectors in the plane is the multiplicative identity property. So our multiplicative identity property simply states that 1 times vector u is equal to vector u. So this concludes our list of the properties of vector addition and scalar multiplication in the plane. I hope you found it helpful, and we'll see you next time.